Okay, I wanted to briefly talk to you about your first group of readings and kind of just give you a quick overview on them. So I want to go just real quickly go into the readings here and go into the Unit 1 readings and show you the topics. And I'm just going to go right through them here. And what you're looking at here is, your general introduction to physical geography, also known as earth science, is we want to basically understand sort of the geography and understanding the science on how resources and the Earth's environment in terms of the biosphere, geosphere, which is the Earth's crust, or the lithosphere, the atmosphere, and the hydrosphere, which is the Earth's water, how they all are spatially distributed and interconnected with one another. And that's what you're talking about right here with that text. And then I want to talk to you at some point in the semester about, we're going to have activities of how we're using new technologies to make digital maps, we call geospatial technologies, and how geospatial technologies like GIS, remote sensing, and global positioning systems, which you're quite familiar with on your phones, how they are being used to make maps to understand the physical distribution and patterns of the Earth's natural environment, all right? And so throughout the semester, you will have a couple of exercises, and one is coming up called the Mapping Lab. And the Mapping Lab, you will specifically use a variety of geospatial technologies, and you will learn how to use digital maps a variety of times throughout the semester. And a number of careers are very much in business and in healthcare, in law enforcement, where with like drones and whatnot, that we know that these technologies are used tremendously to and are transforming jobs and careers. So, throughout the chapters you're studying, you're constantly going to be learning and seeing how maps are indicating and showing how different topics and themes within earth science and physical geography, how the oceans and the land masses and how humans in particular are living within these patterns, and how the geography of the earth changes over time, and what are the implications and consequences with humans. And you think about agriculture and weather, and you think about volcanoes and earthquakes and ecosystems and how they're all interconnected together. We will certainly be talking about and seeing those topics throughout the entire semester. So that's what you're going to be seeing. Topic 2 is learning about science and geographic inquiry, where, in this class, we really want to understand the scientific method, and we had an activity we were going to do and use the scientific method on understanding plyometric exercises, and I decided to cut it, but I still want you to be looking over it. But when we try to understand and make an inference on a pattern that is occurring, we use science to understand through a series of processes, and I expect you'll understand the steps that are laid out here in scientific research, that when we talk about understanding and making a prediction of why and how things happen, they are based on a very structured set of questions that we ask, and that they allow us to know objectively that we have went through these techniques and questions. And in particular for us, we're looking at geographic or spatial inquiry. Is I would really like for you to really look at, these specific types of questions that we kind of go through in the scientific method. Is you could ask a geographic question: is why is some farm ground and soil better than others to grow higher yield? Then you would have to identify, okay, well, what kinds of data is out there about soil fertility to maybe help me in elevation and soil moisture? What data sets could I potentially gather to ask and answer why are field Y and field B, why is one more productive than the other? So we could potentially look at what do we think is some of the factors that might give field A an advantage over field B. Then, once we gather our data, we start producing maps and tables and look at statistical patterns and relationships to evaluate, is there indeed a reason that there's something about soil structures and fertility in field A and the soil type, and maybe soil moisture and other stuff, that we could actually then summarize the differences between field A and B, and then we analyze that geographic information from the maps and tables we create, and we then can objectively answer and infer a pattern or a process. So really get familiar with understanding the spatial processes. Knowing where something is one thing, but knowing why it's where it's located is the other, and that's what we call spatial analysis. And that's what we're going to be doing at times in the semester, is taking geography beyond just saying and memorizing where things are. We want to know why they're located where they are. Why are some of the most economically advantaged areas? What is unique about them versus other areas that are less advantaged? There are, simply put, some states or some counties that have innate advantages for economic development than others, and that's the kind of work I like to do. For us, it's on physical geography. Why are jungles only located around the equator, whereas deserts are about 20 to 30 degrees latitude off of the equator? We will be assessing those patterns. So just make sure you go through and read that, we just don't casually answer scientific questions. We go through a process, and I'll expect that you'll be going through this right here. The scientific method, and you got a nice video here, and I expect that you'll go through and you'll follow the scientific method, that no matter what area of science you are in, whether it's geography or geology or chemistry or physics, that you will see that there is a set of key questions that you're familiar with. So when you're conducting scientific research, you'll see that there's a series of parts that you have to answer. And there's a couple of times throughout the semester where I very well might be referring you to go through the scientific method steps to propose and address a question. So, when you're going through this page, keep in mind that this is a science class, and when you are making references or inferences to questions I'm posing, try to think of the scientific method, that opinions really don't matter much without supported facts and data to support those opinions. And make sure you're familiar with these steps that are here kind of bolded or at the top of these headings, so you're familiar with what's an independent variable, what's a dependent variable, so if they come up in an exercise or whatnot, you'll be ready for them. On the very first, one of the early assignments is you're going to be doing on mapping locations. It's called the Mapping Lab. You're going to learn about the geographic grid system, which is one of the hallmarks of any geography class. It's basically understanding, how do I locate something exactly on the Earth with like a GPS unit using latitude and longitude. And then you might want to know, why is it located, or what is around it, its relative location. So, you could map an interstate and give me the exact latitude and longitude of an interchange where two interstates meet, like in Effingham, Illinois. But then, next to an interstate interchange, we also like to talk about near an interstate where two interstates, north, south, and east-west roads meet. There's often a set of businesses that like to locate near those high movement areas for traffic. And the relative location is where are you in relation to something else. So, for example, a lot of other smaller stores like to locate near Walmart because they want to be near a store that's generating a lot of traffic. So they give you some examples here. Make sure you're very familiar with understanding the idea of latitude and longitude, and understanding the north-south positions off of the equator versus the east-west position off of the prime meridian. So you will see that when we're talking about longitude, we're wanting to know about where are you from the central meridian going through Greenwich right here. And longitude tells you where you are east or west, primarily of London, England, which we call the Greenwich Meridian. Whereas when we're talking about latitude, we're trying to know where are you in relation to the north or south of the equator. And when we talk about latitude, there are key lines of latitude that are very important for many areas of study in geography, and they identify zones. And it'd be very nice and it'd be very helpful for you to have and kind of have these in front of you when you're taking quizzes and tests. They really help you identify, you need to know that the Tropic of Cancer and the Tropic of Capricorn and the Arctic Circle, these are going to be very significant numbers that you'll use in particular on the Sun Angle Lab, right? So I would say you can't miss going over this. This page is very important for a number of labs of understanding the power and importance of locating. So when we're talking about physical geography, we really want to know where things are and where are they in relation to other places, right? So there's one thing about locating where the actual coordinates are of a cell tower, but where you live and how far you live from cell towers determines your service. That's relative location. So I expect you'll be able to know those concepts. The last concept that I'll talk about in this set is being very familiar that the data that we collect from digital sources is called spatial data. Your cell phones generate them as you're moving. Spatial data is data that is tied to a location. Non-spatial data is often data like in a spreadsheet that is not tied to a location. And so there's a series of technologies called remote sensing, which are satellites in space, GPS, which are satellites that specifically help people track their location. So if you're working in agriculture and you're mapping how a tractor is moving across the field applying chemicals, GPS satellites can actually drive a tractor and have the tractor will drive itself because it will know where it's located. This is why we're moving in. GPS is what's being built into many cars now, like Tesla, to help cars basically self-navigate. And you can only imagine the scale. That's GPS. And then we're going to use what are called GIS systems to actually assemble and utilize data to look at physical geography features like tornadoes or earthquakes or volcanoes. And we're going to produce digital maps and analyze them for patterns. And so you need to be very familiar with GIS, GPS, and remote sensing technologies throughout the semester. You're going to get very familiar with the use that physical geography and geography in general uses lots of data. And we're getting increasingly more and more digital data, and in particular, it is tied to location. So if you've ever been out driving, sometimes your phone will start to come up with ads that are actually referencing businesses that are nearby. It's a very good indicator that your cell phone is basically converting you into a data set, and it's trying to tell you that your relative location is in proximity to a store that it thinks you might want to stop at. Some of you might have experienced that, and that literally is what we're talking about right now. So if you have a cell phone and you've ever noticed that ads or indicators of business ads or coupons will pop up, often when you're near or adjacent to a business that's near your phone's location, your phone is using absolute and relative location with GPS technology. Basically, tell your phone you might want to shop at a specific store. So GPS is also used in law enforcement a great deal when you're talking about, certain types of criminals have to wear an ankle bracelet, and it won't allow them to get within a certain distance of certain areas like daycare facilities or schools, And there's another good example of where GPS helps to control your location and relative location, keep you away from areas that law enforcement doesn't want you near. So that's the first part of the reading, and I'll be putting a video right here, kind of summarizing my quick overview. And at the end of this, you got a quick summary of kind of what we've been talking about, of what we're going to be learning in physical geography. And this short paragraph is just sort of a quick overview of what we're talking about. So tomorrow I'll be putting this up for you, and I'll be doing it for each one of these sections right here. and that'll be it. So, I will go, let's see here. And I want to, I'm sure, stop share, and I will end this